time to do something. And what can it be? I need to finish with line modeling. We start at the moment when we, how to say, become acquainted with the Carson's model. Carson's model is two magnetically coupled wires over the conductive ground. Yeah? Yeah. But we don't have two wires, we have three wires. And we need model for zero sequence. Again, wire, wire, wire. Some source, ground, current returns. We need voltage drop at the unit of length. For example, for 1 kilometer. Yeah. Current source 1/3, 1/3, 1/3 of current. I need to know voltage drop. This will give me what? If we will have this voltage drop, this will yield us resistance of line in zero sequence mode. Well, let's assume what we knew line geometry. So it's a wire with known radius, A, B, C, and we have AC, B, C, and this will be D, A, B, we knew geometry. One important moment. In general, if we look close, here's our ground. So K are not uniform. And the line is not 100% symmetric. It's quite common to assume that the line has a full cycle of transposition, assuming capacitance against ground symmetry. You know, of transposition. Here, some. To transpose the line, we need to swap wires at high voltage line to equalize capacitance against ground to prevent losses from this non-symmetry. For short line, it's not true. It's for relatively long lines, but when we create such model, it will be much more difficult to perform calculus on non-symmetric line. Error from from assumption that we deal with fully transposed line. When line is in reality non-transposed, it's somewhere from some 5 to, in worst case, somewhere around 9%. For protection calculus, it's not a giant problem. If you really concerned about error of line non-symmetry, you will need to perform modeling in phase coordinates. Behe-Carson model. It takes much more labor. One more trick, somewhere in the middle. Take, if you need a calculus, for example, for phase B, create model as it symmetric, the full transposed, but with data from phase B. It's in the middle. Precise modeling, it's possible, but it's really labor consuming. For understanding, I saw this model written in paper. My colleague did it. It was written on 2 rows of paper. One row occupied this row of tables and another row the third one. 2 rows of paper to this model, precise model for 330 kilowatts line. It's really, it's possible, but it's labor consuming. Okay. So in my case, what I'm dealing with, one half of current owned via resistance, self-inductance of the wire. This will be LA. Same thing. Self parameters. See? Ground. Yeah, here are self elements of the phase. What else? Set of mutual inductance. AB. BC and MCA. Yeah. Here all this close. Full current. And I need this voltage drop. It will give me necessary zero sequence resistance. Here's my model. Like this current source is strange. Yeah, and this one will be 1/3. Here is my model. I separated self elements for phase, self resistance, self inductance, and move to our couplings between phase. How can I deal with these couplings? AB, AC, yeah? What will be here? Again, meter of AB, meter of BC, and here BC, and one more, AC. See what I did with my model? I put this model, Carson's model allows me to substitute two wires over ground with wire self-resistance and move to our mutual resistance. Here is one, here, I'm writing like this, no transposition cycle. So within one period, or one distance of transposition, I can write a system of iteration. Okay, I wrote it. What will be my system? For A phase, voltage drop will be 1/3 ZR, self-resistance, plus metal AB plus metal CA. For B phase, it will be 1/3 of the current plus metal AB plus metal BC. And for C phase, I will have 1/3 of current, self-resistance of C phase plus metal BC plus CA. Here is my set of voltage drops. It's within one distance of transposition. What we will see on transposed line. For example, I have started A, B, C phase. It's one distance. Now, one swap, maybe a bit longer. Second swap, and so on. I will have one transposition barrel, say one, second transposition barrel, and so on, until phase do full cycle. It's done, in reality, it's done to equalize, I will repeat, to equalize capacitance between phase and ground. For 110, it's a rare thing. For 330 and above, it's a mandatory. Because asymmetry in capacitance at high voltage produce terrible equalizing current and huge losses. So it's absolutely normal practice to design net width transposed line at high voltages. Where is my nice transposition? not mine. It should be somewhere. Where the line parameters are. Estimation for one. It should be somewhere. So for full cycle, we will have what? Common S U A plus delta U B plus delta U C. You understand why? At first, A phase is at top, then B phase, then it will switch to C phase. So for one wire, with full cycle transposition, one wire will take both free positions. If one wire takes all free position, I can use calculus results from the from this one, first stage, let's say, and just swap. I need a picture of transposition barrel. Next time, go to your picture. I knew where one is. Special tower with very complicated. Up, down, down, up. They call it barrels. So, my voltage drop, for example, for A phase summary will be 1/3 of current ZLA plus ZLB plus ZLC plus double MAB plus ZMBC plus ZMCA. Triple self plus double sum of material. It's for A phase. Now more complex. I need per unit of length. I need in volts per kilometer. I need per unit of length. Per unit of length, I need to remember one thing. I have three, in full transposition cycle, I will have these three, segments. Since I have three segments, some voltage of drop per 1 unit of length will be 1/9 of current cent. Triple self plus double ZMAB plus ZMBC plus ZMCA Now, what I'll do, I will put values from Carson model here. I will put them here and here. Carson's forwards should go here. So my summary voltage drop will be current sent by 9 divided by 9 triple wire resistance plus triple active component, so it's 494 plus 3 multiplied 0 14469 decimal logarithm of wire length, and here will be GMR, plus 6 multiplied by 494 multiplied by 10 minus second. It's cool, but it's not all. Plus, need to continue. One moment, I will continue. Plus 0 14469 multiplied by 2 and multiplied by decimal logarithm of Z divided by DAB plus logarithm of this divided by DBC plus decimal logarithm of depth divided by DCA need to simplify this. I need to simplify. One second. Possible I did it right. So it equals 1/9 of the current, triple active resistance of the wire, plus 9 multiplied by 4, 94 multiplied plus 14469 multiplied by, here should be triple decimal logarithm of the Z divided by GMR of the wire plus double logarithm DAB plus logarithm plus logarithm 1, 2, 3. So this will give me following equals to 1/9 of current, triple resistance of the wire plus 9 multiplied 4, 94 multiplied plus J 0.14469 multiplied by 9 decimal logarithms of divided by square root, not the square, but the root of the 9 power of geometric radius in cube multiplied by DAB, DBC, DCA in power of 2. Oh, what a nice formula. So, per unit of length, I'm getting per unit of length voltage drop will be current multiplied by 1/3 of the wire resistance plus 494 multiplied by 10 in power minus 2 plus imaginary 0.14469 multiplied by decimal logarithm of depth in the ground here, root of the power of 9 from GMR radius in cube multiplied by distance AB, BC, CA, here should be square. Up. Here is per unit of length. Now it's not so disastrous. I hate this. Because real resistance in ohms per kilometer will be what? Triple delta O divided by, yep, what I'm getting, ticket to lunatics asylum. Zero sequence resistance in ohms per kilometer at 50 Hz will be wire resistance plus 0.1482 plus 0.43407 decimal logarithm of divided by root of power 9 geometric radius in cube DAB, DBC, DCA square. Yup! Nice formula. to simplify, everything, average distance can be used as root of power 3 AB BC CA. Average distance. Average geometric radius R sigma of GMR, but be careful, it's a GMR for whole line. Do not confuse with GMR of free wire system. It's a GMR for whole line. So average geometric radius will be root, not square, but of power 9 of case multiplication, geometric average of wire system, and average diameter in power of 5, or cubic root from RG dV 5. Now, finally, I can stop writing zero sequence resistance as wire resistance plus 0.1482, plus J 0.43407 multiplied by decimal logarithm of divided by R sigma. Here is what I needed. Zero sequence resistance from line geometry. Or more. In ohms per kilometer. As a next step, I can derive direct and negative sequence resistance from this. Most work was to obtain zero sequence resistance. It's most complex. When I have zero sequence model, I can easily derive direct sequence model. To do so, what I need to do? Here is my line, ground, unit of length, delta O. I just write here A squared and A. I just apply not a single current, but an ideal direct sequence. Absolutely no crime. Why? Because here this current will be plus A plus A squared equals to 0. I can do it. And nobody stops me. Voltage drop between transposition barrels 1 and 2 at the first stage will be one-third ZLA plus A square ZMAB plus A ZM CA. Or for the second, so this one between barrels 1 and 2, second stage between, or second segment of line will be between barrels 2 and 3. So between barrels 2 and 3, I will get ZLB plus A meter AB plus A squared Z meter BC. And number 3, last one. Delta UA3, it will be same ZLC plus A square meter CA plus A ZLBC. Complete voltage drop for full transposed line will be delta UA plus delta UA plus delta UA 1, 2, 3 will be sum of all, voltage drop from all transposition distance line segments. What I will get? Will be 1/3 of ZLA plus ZLB plus LC plus here should be A plus A squared multiplied by Z multiple AB plus Z LBC plus Z LCA. And what is value of A plus A squared? What's this? Plus 1 plus this is A. Its magnitude is 1. Yeah? Minus 120. This is A squared. What will I get if I add 120 degrees? What's the value of orange vector? If this is 1 and this is 1 and this angle is 120 degrees. $120? Really, or 120? Or maybe 60? Or 120? Take minus 1. Because 1 plus A square equals to 0. Check. Next thing. So my delta O is 1/3 of current ZLA plus ZLB plus ZLC minus ZMAB plus ZMBC plus LCA. Fine? Now, if I put inside known value from Carson model at 50 Hertz, I will get voltage drop for A phase as L1 plus 0.14469 logarithm average geometric radius of my wire minus 0.14469 decimal logarithm of Earth's depth root of power 3 from DAB, DBC, DCA. Haha. Now, because I have a minus sign, I will write current, resistance of wire plus 0.14469 logarithm 3 DAB DBC DCA divided by so, resistance in direct sequence will be R wire plus your 0.14469 dV divided by average geometric radius of my wire. Haha, yes! I have it. It's a direct sequence resistance in ohms per kilometer. And do you see one interesting thing about mutual inductance? But it's coupling between wires works differently in direct and negative sequence. I can show it with the I can use use value delta Zn to represent an influence of mutual inductance. It will be 494 multiplied by 10 power minus 2 plus 0.14469 logarithm of divided by dV. This is what's physical meaning of this value? It's an average of face-to-face mutual resistance. Average of face-to-face mutual resistance. I can write what? Zero sequence will be line resistance plus double mutual elongation. Direct sequence will be equal to negative sequence and will be line resistance minus it's all in ohms per kilometer. And here I see one moment. they are not equal, but they are, let's say, in same order of digits. We will see huge difference between direct and negative sequence resistance. Line resistance will be double direct sequence resistance plus zero sequence divided by 3. This mutual difference is divided by 3. Quite significant thing. I need to repeat it. I repeat it. I wrote these formulas assuming full transposition cycle. If you deal with a line without full transposition cycle, go back to Carson's model and go back to the point where I assumed 3 elements and calculate precise elements for assume your line is 1 segment, not 3. It will cause you problem because you saw I simplified. Really, I simplified my formula because I had this a plus a squared. If you need precise model, you will not get this. But 5% really difference. But if you need to prove it, be ready. Precise model without the simplification takes a row, 2 rows of paper from there to there. Okay, Ivar wrote it in quite huge font, but fact, it's giant. One more moment. All I wrote is without what I omitted, lighting protective cable. Yeah. For all the for very old line, protective cable was uninterrupted. Later, because mutual inductance and capacitance between phase and protective cable are not equal, they always current circulate. To stop losses from this current, design was changed to interrupted cable. It means what on each distance between towers, on one side cable inserted, on the opposite side one insulator and spark discharge gap. Until what started? OPGV value. Protective cable. Inside plastic, some have metal, this tube, and there should be a fiber optic. Where it is, I don't know. 1 second, I will. Oh no. Maybe I can confiscate. And you went.
Another one. തിരിയാൻ സെൻസർ ഉണ്ടാവും. സെൻസർ കേടാണെന്ന് ചോദിച്ചു. സെൻസറൊന്നും കേടല്ല, സെൻസർ കറക്റ്റാണോ അതിന് ഞാൻ നോക്കി കണക്ഷൻ ലൂസ് നോക്കണം. അതിന് നോക്കി വിളിച്ചാൽ സെൻസറിലേക്ക് വയറാട്ടെ രണ്ട് ദിവസമായി സാധനം വർക്ക് ചെയ്യണം. സിമ്പിൾ സാധനമായിരിക്കും. അവര് സകലം നോക്കി ഒന്നെങ്കിൽ പ്രോഗ്രാം പോയിണ്ടാവും, പക്ഷെ ബാക്കിയുള്ള കാര്യങ്ങളൊക്കെ വർക്ക് കറങ്ങിൽ മാത്രമല്ല സ്പ്രേയിങ് ഓട്ടോമാറ്റിക് ചെയ്യുന്നുണ്ട്. ഞാൻ പ്രോഗ്രാം പ്രശ്നമില്ല, പ്രോഗ്രാം പ്രശ്നം ഒന്നും വർക്കില്ല. എന്നിട്ട് ഇതൊക്കെ പഴയ മെഷീൻ 2008 മെഷീനാണ് പറഞ്ഞത്. അതിന് സർവീസൊന്നും ഇല്ല. അപ്പൊ അതാണ് എനിക്കിപ്പോ സെൻസറിൽ വയറാട്ടെ കിടക്കായിരുന്നു. അതാണ് റെഡി ആക്കിയപ്പോ ഞങ്ങൾക്ക് എന്താ പറഞ്ഞാൽ ഞങ്ങൾ ഒന്നും വേണ്ട ഇങ്ങനെ ഇരിക്കും കുറെ നേരം ഞാൻ സാറൊക്കെ ഇരുന്നിട്ട്. എന്നിട്ട് എന്താ നോക്കും വല്ല വയറ് ചിലപ്പോ കോണ്ടാക്ടറിന് വയറിൽ പൂരി കിടക്കുന്നുണ്ടാവുക ലൂസ്.
Second one also disappeared. Okay, what can I do? I can do nothing. Okay, what I need to do? I need to tackle. So I have A, B, C phase, yeah? And protective cable, I will use T from Latvian truss. It's my protective cable over here. I need to, here will be IC and move to our couplings. Oh. My problem, if I have this OPGV used to house fiber optic cable, it will be uninterrupted. What will be my model? Ground, current source. Oh. Here flows triple E null, but ground component, and also here will be current in my protective cable. I will write it as triple zero. And I need what? Delta voltage drop. How will my model looks like? My model will be ISAC truss, protective cable active resistance. T mean truss, it's cable in Latvian. Here, L, L1, ZLA, L1, ZL, B fāze. Tā, ar kur man plugging. Here I'm plugging 1/3 of my current source. Next, MAB MBC this one is AC, and what next? 1, 2, 3. A to cable, B to cable, and this one C to cable. Ground. Yeah, case model you need to solve. You like it? No? You definitely like it. See, that's the more interesting thing. When we deal with this, and this, they will produce mutual resistance. And this resistance will decrease observable line resistance. Because current in phase goes this way, and this one current in your protected wire goes, we have two, one in ground, one in your protected wire, and it goes opposite direction. This element I can get without any problem from Carson model, but I need to remember one thing. 0 sequence, 0 sequence, 0 sequence has sums, triple 0 sequence. And this triple 0 sequence current distributes between protected wire and ground. Remember, this factor of 3, because my cable is in the neutral. So all resistance of my protected cable in 0 sequence is 3 cable ohm active resistance plus 4, 94 power minus plus yep, 0.14469 decimal logarithm of this divided by GMR for my cable. Next, mutual plus 0.14469 multiplied by decimal logarithm divided by dA cross. It's a distance between A-phase wire and protective cable. Same, of course, for B and C, and for full cycle of transposition for whole line. Average bit farther cross will be Z mu A cross plus ZMB cross plus ZM. All three phase. This will give me for 50 Hz 1482 plus 0.43 407 logarithm Z in power of 3 dA cross multiplied by dB cross multiplied by dC cross. For zero sequence resistance of line. What kind of model I'm dealing with? Own resistance of protective cable and phase multiplied by 3. 3 of them. One third of phase Pareto T. It's resistance of wire in zero sequence and one wire to cable. Same thing. The same. Ground, ground. Oh. And my voltage drop. In the phase wire, zero sequence drop will be 1/3 of current, zero sequence resistance of my phase minus current in protective wire, mutual resistance between wire and cable. Because we can write voltage drop in protective cable. It will be triple zero sequence current in our cable multiplied by zero sequence resistance of our cable minus triple mutual resistance between phase and cable multiplied by 1/3 of current. What is the voltage difference between ends of protective cable? We assume superconductive ground. So it is 0. Substituting from second to 1, I will get for one phase voltage drop 1/3 of current, 0 sequence without protective cable minus 1 second mutual resistance phase to cable square divided by 0 sequence resistance of protecting cable. It's for one transposition, one length of transposition between two bars. Common one will be triple. So finally, zero sequence resistance. Of my line will be zero sequence resistance of phase without cable minus mutual ace cable divided by zero sequence resistance of my cable. Here it should be squared. Or I need space. In presence of protective cable, zero sequence resistance will be resistance of Y plus 0.1482 plus 0.407 logarithm in power of 3 divided by GMR of your Y square minus 0.1482 plus 0.4307 logarithm of the Z square divided by distance between phases and protective cable. This should be put square and divided by triple resistance active of your cable plus 4.94 multiplied by 10 minus plus J 0.14469 decimal logarithm of that divided by GML radius of your protective cable. Here is nice formula for complete line. with protective cable. Very easy. Why I'm not writing formula for direct or negative sequence? Influence of cable can be omitted. Here is nice tiny formula. I'm not sure everyone wants to repeat this step, but here it is, zero sequence formula for complete line. That's what you need to put in your model. And it's only low frequency formula and with small shortcut, assuming line fully transposed. For a transposed line, you will need to do step back and your formulas will be bigger. So if you unlock and use the guy who need to calculate this